Hello, good day everyone. Happy to have you once again in this section. Today we'll be looking at software development principles. And I'm Ijoma Jacob by name. It's a pleasure to have you in this section. So straight we're going to content of our presentation today, to the content, and we have few things to discuss before we round up today. We're looking at software development principles, and there are four things in our content. The principles that must be adhered to, necessary to be adhered to for a maintainable, scalable software to be developed. And not only maintainable, but can scale as well when the need is there. So we're looking at one of them, Yagni, then Kiss, then the dry, then the solid principle. Of course, at the end of this exposition of software development principles, the audience should be able to understand the principles that should be followed in developing softwares. And these are softwares that can scale when the need arises. Now, these are the things that you ought to understand: the Yagni, the solid, the keys, and the dry. So without further ado, let's go in and begin to explore them one after the other. Now we have Yagni principle. You aren't gonna need it. It's a practice in software development which states that features should only be added when required. Of course, it's necessary that this principle be adhered to, that features should only be added when required, when needed. It plays a lot of role in making your software development, your application, the code base to be concise, to be small, because the size matters. It determines how it's going to load in the user's devices. So the place of Yagni is so important. So there are some ideas behind it. Number one, granularity. Granularity. It should be granular. Number two, there should be balance. And when this two comes into your software in the process of the development, it makes you attain the you aren't gonna need it principle. And this a practice, not just should remain as a principle alone, it should be a practice in software development, and you should endeavor to carry it out so that it will give you a concise uh, application size, which will improve the load performance, which will improve the loading and the performance also of the application in the from the user's end uh, point. All right, we move to KISS. KISS is an acronym for Keep It Simple, which is also necessary. As you can see in my diagram here, that you have to keep, as you nest your applications, you have to make it simple in such a way that it will be understandable. The process should be as simple as possible. Now, you can see the tree that is being illustrated here on the diagram on my slide. And you can see the one on the right hand side, how it is nested. The nesting is somewhat ambiguous. Is not clear, it's not distinct. In fact, keeping your software, adopting this principle of simple and keeping your software code base and writing your method and functions and classes and interfaces, making it simple as possible, your loops, and then making it as simple as possible, it helps your code and your application to be maintainable over time. And in fact, somebody said that simplicity is the highest sophistication of is the highest sophistication in life. So, being keeping things simple is a tool and a strategy that should not be overlooked, especially when it comes to software development. All right, thank you. Move to the next one where we're considering DRY. Don't repeat yourself. Don't repeat yourself. In software development, of course, this is a principle that applies as well. Definitely in speech presentation, of course, you don't just keep repeating yourself. It bores your audience. Also, that's in speech presentation, in writing and all that, you drive your point home, make it concise, and you don't just keep repeating yourself. Also, in software development, you don't just keep writing codes that are doing the same thing on different modules or different classes, repeating it over and over. It implies that you don't seem to have got a general view of the problem you actually want to solve. If you are solving a problem, you are making sure that you are creating a solution. And if a solution you have created is kept, then and there's another problem that arises, that this solution that you have provided before can solve a bit of it, if not all. If it can solve all of it, you don't need to repeat yourself again, writing the same code to solve a problem that came at point A. When you have provided a solution at that point A, then a problem that came at point B will look similar to it, and you are not creating another solution again for that problem. Why not leverage on the solution you have created earlier? And if there's a little improvement and all that, you can just do that and make use of it to solve problem B at point B. So the need for avoidance of repetition. Repetition is so important. So every piece of knowledge must have a single and unambiguous authoritative representation within a system. So important. All right, so still on the dry principle, we are looking at every piece of knowledge should what? Be single. It should be single. It should not be ambiguous. It shouldn't be ambiguous in order to what? To also keep your software concise and easy to load, even when in production or in development, but especially when it's in production. So not repeating yourself actually makes your software manageable and small in size, which will later improve the user's experience in terms of load time or loading duration. All right, so we're looking at solid. Solid encapsulated order principle in it. The SRP, OCP, the LSP, the ISP, and the DIP, DIP. So solid is also on its own an acronym, which S is actually single responsibility principle. And what is single responsibility principle? We'll get into that as we proceed. Then look at the O, open closed principle. Then L is curve substitution principle. Then the interface segregation principle. Also, we look at the dependency inversion principle. All right, so if we pick them one after the other, then you come to terms with me that the principle, when applied, has a purpose, has an intention. And what does it intend to do? It intends to make what? It intends to make your system easy to maintain and to extend as well over time, to be extended, to be reused over time. All right. So if you start with the S, the single responsibility principle, it's actually talking about most at times object-oriented programming. This mostly applies as well and very, very important in that aspect. And what is that? Single responsibility principle. A function, a method should do a single thing, should do one job. Of course, it plays with normal principle that we have in life. definitely you should have a spoon. You should have a spoon for a single reason, a single purpose, to solve a single problem. And what is it? To eat with it. Now, it's abnormal for you to have a spoon and hoping to one day to make the spoon a writing material. Well, that is not the sole purpose why it is made. So a function should have a single responsibility. Then open close principle. A software module, it can be a class or a method, should be open for extension, but closed for modification. It should be open for extension. It should be extended. It should be used in other parts of the application. And when this is used, is made extendable, then the place of repetition is avoided. So it should be open for other parts of the application to make use of it. Then we look at the least curve substitution principle. These objects, this points to the fact that objects in a program should be replaceable with an instance of their subtypes without altering the correctness of the program. Without altering the correctness of the program. So objects in a program should what? Should be replaceable with an instance of their subtypes. In other words, just as it implies, substitution principle. Substitution should be that you are taking one thing and you're replacing it, you're putting it with another, and not removing it entirely. So the scope principle is of the idea that objects in a program should be replaceable with an instance of their subtypes without altering the correctness of the program. If you are extending a class or extending an interface, yes, when you extend in such a way that it can inherit the base class. It can inherit from the base class. And when it inherits from the base class, it plays a role of more or less like substituting the base class. And when that happens, it helps also your code to be concise, not to be bulky. For you trying to use a program, an object that, or try to create an object that is already created that can be also what? That can be derived from, can be inherited from, if I be putting it in a way you will understand. Some trait in a father can be transferred to the child. And in that case, those traits does not mean that you don't need a father. The child is there, he has the father's trait, and he also has his own trait as well. And in some way, it seems it's being substituted for the father. Yes. You say, that is the concept. In software development, classes can inherit interfaces, extend them. Classes can inherit from other classes, their attributes, and also have additional properties in their own object as well, in their own domain. Therefore, it seems as if they cannot do without, they can do away with that class. But no, the class is still there, but they extended it and is was using the class now in form of is substituting it. But that doesn't mean that the base class is out of the way entirely. It should be available as well because the child class is inheriting from the parent class. All right, we're looking at the interface segregation principle. Clients should not be forced to depend upon interfaces that they do not use. Yes, clients should not be forced to make use of interfaces that they do not use, and that is where it also comes that we still have to be there still need to be separation of concerns in this stuff. Separation of concern. If I have a function or a method that is calculating For example, the area of a shape. And someday, I said, okay, I felt that I need to improve on this thing. Let me have a method also, or class as well, that because class has method in it, of course. Let me have a class, or as the case may be, that will calculate volume this time, and we're able to handle volumes of shapes. And of course, that tells us that the ones shapes that has area that can areas are calculated are quite different from the shapes that volumes are calculated. These are solid, of course. These are a bit flat and all that. Now, in getting the volume logic into the interface that has the calculation of the area logic, then if we want to make use of it, it implies that we'll be forced to make use of the volume as well. If I want to calculate the area of of a sheet of paper, when I implement that logic, it has two logic inside, one for calculating area, one for calculating volume. I'm now forced that if I'm implementing one, I must implement the other one. And definitely there's no way I can calculate volume for a shape that only area can be calculated on about it and not volume. So having a volume logic inside makes it difficult. I'm forcing the execution of the volume on the methods and the solution I'm trying to provide. Therefore, there shouldn't be separation of concern. Either have an interface for volume, have an interface for area. Then, when you are calling one, you know you are calling only that particular, implementing only that particular interface, or calling only the method inside the interface that calculates only volume. And that points us to the first principle where there is single responsibility principle. So it's not when you make your responsibility for an interface to be true, the method inside to be true, define a method inside or a signature inside to be true. When one is implemented, you are forcing whatever implements that one to also implement the second one. And in that case, you are violating the single responsibility principle as well. So interface segregation principle tells us that there should be separation. Segregate them. Let them be apart. Then move to the one dependency inversion principle. Program to an interface. Program to an interface and not to implementation. Program to an interface and not to implementation. Work with interface. In that case, when you work with interface, that tells you that you may have various interfaces. An interface have a single responsibility, has a single responsibility. Then we can make use of interface in abstraction for some logics that have been written. I may put it this way. For example, a simple illustration, but quite a technical one, that if I want to code or bring up a solution that reminds users of their passwords, definitely, of course, in that I must have a database where the users store their passwords earlier when they interacted with that system. And possibly there is other thing I need to implement to help the user to remind him or her of his password when interacting with the system earlier. Then I must make use of a database. Now there's a database, there's a connection for that, and there's a password reminder actually. Now bringing the database into the password reminder method and calling it from there means that the password reminder will depend on that specific database. But where the case comes that I need to switch to a database, the password reminder will fail to work in that case because it has been forced to depend on this database and this type of database. So when there is a change in database, the password reminder fails to work as expected. So in that case, we make it in such a way that it is flexible, that the database interface is separate, that irrespective of the changes in database in the future or the logics in the database, whatever it is, that will not cause the password reminder not to work. So changing from MySQL to PostgreSQL or switching everything, they are independent. They are independent. So depending on it, in other words, the database is abstracted and the password is kept also abstracted. So they depend, the password depends on the database, abstraction of the database, separation of the database. And the database is quite separate from the interface. So when there's a change in the database, the password reminder can still work. So it's a kind of the system that it affects the system design and also helps in for the software to be maintainable and be extendable over time as the development proceeds. So those are the principles that we deal with in this software in this class. And in summary, looked at YAGNI, looked at case, looked at dry, and looked at solid. And what is the YAGNI again? You aren't gonna need it. If you don't need it, don't bring it in. Don't luxury. There's no luxury in software development. That what I don't need, I just brought it in and kept it there. So there should be keys, and keys keep it simple. Keep it simple. There are times it can even be stupid to do that, but all the same, keep it simple. Then dry. Do not repeat yourself. And solid. We looked at the acronym of that: open close principle, single responsibility, list curve, and dependency in functions, and all that. Then we'll come to the conclusion of our presentation. Adherence to the design principle, complying to that, working with it, helps development uh, engineers, developers, software engineers to produce a maintainable and scalable solutions. Thank you very much for giving me your attention, and I hope I'll see you next time. And this is where we draw the curtain close.